Hello, my AB children. Here comes section 7.2, verifying solutions. I believe that the amount of space that they gave you for these problems is not big enough. So for me, you're going to see me adjust and use a separate piece of paper so I can write big. But you just might want to write small if you're using this particular note outline. All right, so derivatives can be used to verify that a function is a solution to a given differential equation. We already covered some of this back in section 6.8 when we found particular solutions. Now, particular solutions, if you remember right, normally when you find an integral, you put a plus c at the end. But in particular solutions, they give you enough information for you to be able to find what c actually is so that you have a very specific equation without a c in it, without an unknown. So in particular solutions, they give you extra information and there is no plus c. There's no need for it because you can figure out what c is. What I'm talking about is this extra statement at the end. If they ask you to find they tell you the derivative here is this function, this piece, and they want you to figure out what the original function actually is. This is the derivative. You're going to take it back a step, which means you have to integrate it, and then they're going to give you enough information for you to be able to find what c is and put that into the equation. So that's our goal for these. I don't think there's nothing really new in this section that you haven't seen before. It's just extra pieces that maybe you haven't put together. So this shouldn't be too crazy, but it does take a lot of work, a lot of space. So here I go. You see me putting on an extra piece of paper so that I can work this out with you. Our goal is to figure out what the exact equation for y is, what the particular solution is for y, what the real function would be. And so if I'm going backwards from a derivative and I want to figure out what y is, then I need to integrate each piece. Now I'm going to separate this. You'll see why in a couple minutes here. Oh, integral of 2x squared dx. I just separated it into its two separate pieces because the way I'm going to go about finding the integral is different for each piece, and that's why I'm separating it. Okay, so if I look at this first piece, the e to the 2x piece, we just did problems kind of like this when we did the u substitution section. So I have to put my angle, u equals the angle 2x. That means that du equals 2 dx. I look at the equation, I have a dx, I don't have the 2 has to go to the other side. So 1/2 du equals dx, and now I'm ready to put it together into its new lovely form, and that's going to be y equals the integral of e to the u times 1/2 du. Now you can keep going with that particular term. You can move on with the next term. Constants can come out in front, so 2 times x squared dx. That would be my next take on this. Now I'm going to keep going. Next one is the 1/2 can come out in front. The integral of e to the u du is what I've got going on there. Minus 2. I'm not going to do anything with this guy yet. The integral of x squared. Well, what's the integral of e to the u? It's e to the u, right? So I have 1/2. The integral of e to the u is e to the u, and what's u? Well, u is 2x. So there's the integral of that piece. 1/2 of e to the 2x minus 2. What's the integral of an x squared? X cubed over 3. But then I need a plus c. So if I put this all together, as pretty as it can be right now, it's going to be 1/2 e to the 2x minus 2, I guess I could say 2/3 x cubed plus c. But they gave me information to be able to figure out what c actually is. This y of 0 equals 4 means that when x is 0, y is 4. Right? That's what they're telling me in that coordinate right here. So I'm going to plug that in. I'm going to make it 4 equals. I'm going to find my c. 4 equals 1/2 e to the 2 times 0 minus 2/3 of 0 cubed plus c. And that's going to allow me to calculate out what the c value is. All right, well, e to the 0 is 1. 1 times 1/2 is 1/2. So I've got 4 equals 1/2. 0 times anything, that whole thing just zeroes out, is 0 plus C. And when I take 1/2 away from 4, I get that C equals 3.5. Or I guess you could write it as 7/2. A couple different ways. And then we're going to put our final equation together. Find the particular solution. All right, well, go back to your y equals. We know what y equals. Y equals 1/2 e to the 2x minus 2/3 e to the x to the third. Ooh, x, not e. X to the third. Plus our c value that we found of 7/2. And there you go. That is the particular solution for that problem. It required a little bit of u substitution in the mix. And you're going to see that comes up in a couple of these problems that we're going to do. Okay. This problem is exactly the same, except the way that they're asking the question is different. So for number 2, let me take this away for a minute so we can just concentrate on number 2. This problem is exactly the same as what you just did in part 1. The curve has a slope. A curve has a slope of e to the 2x minus 2x squared at each point xy on the curve. What is an equation for this curve if it passes through the point 0, 4? Well, guess what? Your work would be totally identical to what we just did. Because what does slope, the word slope, actually mean? Slope is your derivative. It's dy over dx, right? So didn't we say dy over dx equals x to the 2, e to the 2x minus 2x squared? And then they said write an equation for the curve, y equals, when it passes through this specific point, 0, 4. So really this is the same exact work that you did in number 1. We're going to say same as number 1. Your answer would be y equals 1/2 e to the 2x minus 2/3 x cubed plus 7/2 if you worked your way through that. Okay, so they might ask it in different ways, but it's really the same work that you would have to do to complete that. Now, number 3, if d to the second y over dx squared equals 1 over, they give you the whole thing. Find the particular solution of y if y prime of 1 is 7/6 and y of 1 is 0. All right, so what are they giving you here? They're giving you the second derivative, and what are they asking for? They're asking for the original problem. So this one, you can think about that. In order to go backwards by 1, it's going to put me at the first derivative. But then I have to go backwards again to get to the y. So this is a two-stepper. This one's quite involved. And if I'm integrating, if I'm thinking about integrating, the form that it's in right now is not a form that I would prefer to integrate from. So like, for example, 1 over x squared, we probably would call that x to the negative 2. So what I want to do is I'm going to separate this thing into separate pieces. I'm going backwards. And by the way, this takes a whole lot of paper. So again, it's one of those, I'll show you. Here it is. This was my first, and this was only getting to the first derivative. And then I went to this page, which you can't even see the bottom of, to get to the second part of it. So this one's going to be a little bit more involved. Let's see if we can do it. We're going backwards by 1. We're looking for dy over dx equals the integral of 1 over x squared. Well, that's going to be x to the negative 2 dx plus the integral, and I'm going to keep this as one piece, right? 1 minus 2x squared. Just break it up into its two pieces. And I'm going to come back to these particular solutions after I get it down to what the integral actually is. So let's do the first one. If I'm x to the negative 2 and I integrate, I am adding a power on, dividing by the power, x to the negative 1 over negative 1. And we'll clean that up in just a minute. But this guy over here, unfortunately, is like a chain rule. And to undo the chain rule, I need u substitution. And so I'm going to do a u substitution with this, where u is 1 minus 2x. That makes du a negative 2 dx. When I look here, I don't have a negative 2, so the negative 2 has to go to the other side. It's going to be dividing by, so it's going to be a negative 1/2 du equals dx. All right, let's use substitute. So it's u squared, right? It's the integral of u squared times what dx is equal to, which is a negative 1/2 du. And each step, we're just going to try to simplify it, make it better looking. This one is x to the negative 1 over negative 1. So that is x to the negative 1 that's negative. And then I have a plus, if I take this negative 1/2 out, it'll be minus a 1/2 the integral of u squared du. Well, the integral of u squared is u cubed over 3. Negative x to the negative 1 minus 1/2 u cubed over 3. I need a plus c eventually. I can put it now or I can wait till the end. Let's keep going with simplifying. Negative x to the negative 1 minus 1/2 times 1/3 is 1/6. U cubed, do we know what u is? U is 1 minus 2x cubed plus c. Well, that, my friends, is dy over dx. But they gave me enough information for me to figure out what the actual c is. So let's see if we can do that. They gave us a coordinate. If I go back to the paper here, they gave us a coordinate. They said that the first derivative, when x is 1, y is 7/6. So we know that this would be 7/6 when x is 1. Plug in the 1 for all your x's. And we're going to see if we can find what c is. It actually comes out nice in the end. Let's see. So I have a 1 that's being raised to the negative 1 power. So that means it's 1 over 1, but it's negative. So 7/6 equals negative 1. Parentheses first. 1 minus 2 is negative 1. Negative 1 cubed is negative 1. Negative 1 times negative 1/6 is a positive 1/6 plus c. Let's see. If I have negative 1 and I add a 6 to it, I get negative 5/6. 7/6 equals negative 5/6 plus c. Swing that 5/6 to the other side, it becomes positive. Now I've got 12/6 equals c. So c is 2. And so my final answer for this part of the problem is that dy over dx, my first derivative, is negative x to the negative 1. You could also write that as negative 1 over x. That's fine. Minus 1/6 times 1 minus 2x cubed, and then plus my c value of 2. That's my final answer for the first derivative. But that's not what the question's asking for. The question's asking for what was the original function. And so now we've got to take this and take the integral of each of these pieces, and that's going to be what the function actually is. So let me add on to my paper here, if I can. Too much paper. Okay, so if I take, trying to get to y equals, I need to integrate each of these pieces. So I'm going to take that negative sign out. It's x to the negative 1, or that's the same thing as 1 over x, minus the integral, I'll keep that 1/6 out in front, of 1 minus 2x cubed, plus the integral of 2 dx. Well, what's the integral of 1 over x? And the integral of 1 over x is the ln. So negative ln of x, we usually keep that with absolute values, minus 1/6 the integral of 1 minus 2x. Well, that requires a u substitution again, right? So I'm going to let u equal 1 minus 2x. We just did this work a second ago. Du equals negative 2 dx, which means that negative 1/2 du equals dx. And so when I put that together into this integral, it's going to be u cubed times a negative 1/2 du. And then this one's easy to integrate, it's just going to be a 2x. So I still need to work on this middle part a little bit. The next thing that I see with it, negative ln of x, this one has a negative 1/2 that I can pull out to join up with the negative 1/6. They become a positive 1/12. And if I integrate a u cubed, it's going to be u to the 4th. Well, u to the 4th is 1 minus 2x to the 4th over 4. U to the 4th over 4 looks like this. And then I got the rest of this. I'm trying to combine this so I don't have to write it so many times, but you kind of got to show where you're coming from here. This becomes a 1/8. We're almost there. 1 minus 2x to the 4th power plus 2x plus c. And then they gave me enough information. They gave me more information in this problem. Let me go back here. They said y of 1 is 0. So I know that I've got a coordinate on the original function that when y is 0, x is 1. That's what I'm plugging in here. So I've got a 0 equals negative ln of 1 plus 1/8 of 1 minus 2 times 1 to the 4th plus 2 times 1 plus c. All right, 0 equals. The ln of 1 is 0, so this is technically a negative 0, plus negative 1, 1 minus 2 is negative 1, to the 4th power is positive 1 times 1/8 is 1/8, plus 2 plus c. I'm stopping for a second because I lost something in the midst. Did I? Oh, I think I want to cry. One. You probably caught my problem already. My problem's up here. What did I forget to do? My problem's up here. 1/6 times 1/2 is not 1/2. It's 1/12. And that's not going to be a big fix, so watch this. All right, so this is 12. 12 times 4 is 48. Again, this is going to be 48, which makes this 48. Now I like that way better. Sorry about that. Did you catch that up in the beginning? Love it when you... See, I need to be in class with you so that you catch me when I do those stupid things. All right, so anyway, I have 2 would be the same thing as 2 times 48 is 96 48ths. And so here's where I'm at. If I take this guy and I pull him... Again, I'm looking at my signs here. Oh, interesting. Oh, my answer key, I think I'm wrong for this next part. So I have 1 over 48 and a 96 over 48. So here's where I'm at now algebraically. I have 1 over 48 plus 96 over 48 plus c gives me 97 over 48, but it's going to the left. So negative 97 over 48 is my c. Which means... put it back in the equation. See at the top of the screen here, this is what my y equals. And so now I have figured out that y equals a negative ln of x plus 1 over 48, get it right, times 1 minus 2x to the 4th plus 2x minus 97 over 48. All right. That, my friends, is the answer to number 3. These are beastly problems. They really take a lot of space. They're not crazy hard. There's a lot of algebra mistakes you can make in the midst, as you can see. But they're not crazy hard. And it is stuff that you kind of already know. All right, they're just remembering this is a place where kids make mistakes, is going between integrals and derivatives for the sine and cosine functions. So this is just a reminder, this box. The derivative of sine we know is cosine. We know the derivative of cosine is negative sine. You can put it in parentheses. You don't have to put it in parentheses, whatever makes you happy. But when you're going backwards, the integral of sine is negative cosine. and the plus c, don't forget the plus c, and the integral of cosine is a sine. So they're just trying to remind you how they work, keep those straight in your head, which way is which. And then we're getting to number 4. And again, number 4 is going to take some space, so I am going to do number 4 on a separate piece of paper. Here it goes. This time they give you, and these are pretty wonky. In fact, I'll show you how I did some of the problems in the practice problems. Again, there wasn't enough space for my writing. But anyway, for what value of k, if any, will y equals ke to the negative 4x minus 2 sine of 5x be a solution to the differential equation y double prime plus 25y equals negative 82e to the negative 4x? So you're like, whoa, that is over my head. And actually it's not. You can do this. We can do this. So you start with your y equation and see how this is what we're really ultimately going to substitute in. And we have to substitute in what y double prime is. Well, I have no idea what that is. All I know is what y is. So you're going to take y and you're going to derivative it twice so you can get to a second derivative so that you can then fill this in. And you'll see the pieces will all come together. So job number 1 is what's y prime so I can get to y double prime. K is a constant, so just treat it like a constant. So this would be k e to the negative 4x. Remember how these work with derivatives. E is its own derivative. But then I have to multiply it by the derivative of the power. So times negative 4 minus 2. What's the derivative of sine? It's cosine of the same angle times the derivative of the angle. And so then you're going to put it together, your first derivative, k, negative 4 I wanted to put there as a coefficient, negative 4k e to the negative 4x minus 5 times 2 is 10 cosine of 5x. That's it. Can't make that any better. So now I'm going for my double prime. What's the second derivative? Well, negative 4k is a constant. E to the negative 4x times a negative 4 minus 10. The derivative of cosine is negative sine of 5x times the derivative of the angle, which is 5. Y double prime is 16, negative 4 times negative 4, k, e to the negative 4x. Negative, negative, make this plus. 10 times 5 is 50, sine of 5x. That's it. That's your second derivative. Now, once you have all these pieces, now what we're going to do is plug these into this equation right here. What's y double prime? Well, y double prime is, and you need lots of space for this, 16k e to the negative 4x plus 50 sine of 5x. Okay, that's my y prime, plus 25y. I'm just plugging right from here. Y, well, I know y is the original equation I started with up here that they gave me. So that's going to be parentheses, k e to the negative 4x minus 2 sine of 5x. All right, here I am, equals negative 82 e to the negative 4x. So all I'm doing is plugging into that equation that they gave me, but I needed all the pieces before I could do that. Now let's simplify it. Let's distribute the 25 and see what happens. 16k e to the negative 4x plus 50 sine of 5x plus 25 k e to the negative 4x minus 25 times 2 is 50 sine of 5x equals negative 82 e to the negative 4x. Woo! Now what should happen at this point, if you've done things correctly, you're trying to figure out what k equals. That's what the job is. What's the value of k? So I've got to go back here. Things should cancel out so that I don't have any terms that don't have a k in it. So I look at this, 50 sine of 5x minus 50 sine of 5x, bye-bye. You're gone. And what I'm left with is 16k e to the 4x, 25k e to the negative 4x. These are like terms, so I'm allowed to add them together. 16 and 25 is 41 k e to the negative 4x power equals negative 82. I think I forgot the k. No, 80. Yeah, 82. No, I didn't. 82 e to the negative 4x. Now think about this for just a second. If you're trying to solve for k, what are you going to do with the 41 e to the negative 4x? You're going to divide by it because they're all attached by multiplication. So k equals negative 82 e to the negative 4x over 41 e to the negative 4x. Cancel, cancel, cancel. 82, negative 82 over 41 is a negative 2. So k equals negative 2. All of that for that piece of information. All right, I chose just 3 problems to do to see one of each kind real quick to make sure that you got this. So practice problem, the first one I want to do, and again, I'm going to do these on separate paper so that I have room enough to be able to explain them. Looking at number 3. See number 3. It says for each differential equation, find the particular solution that passes through a given point. This is like our example number 1. These are relatively simple. We're starting with the easiest one. So here I go with number 3. I want to know what the original function is. They gave me the derivative. I'm integrating 8 cosine of 4x. Now, unfortunately, if I want to integrate that, I need to do it. I guess there's a couple of different ways you could do it. You could do it via a chain rule, which is what I did when I did the examples. Or if you just think about it, the 8 can come out, right? 8 comes out. I've got the integral of the cosine of 4x. And if you remember when I kind of did the shortcut way with these, when we did them back in the u substitution. If I know what the integral of cosine is, the integral of cosine would be sine. So I'm taking, this is really the same thing as 8 times the sine of 4x. But then I have to, remember you're integrating. So instead of multiplying by 4, I'm going to be dividing by 4. So if you remember that kind of shortcut way, that makes this a little bit easier. If not, you're going to let u equal 4x, and then you're going to do a u substitution to it. So either way, whatever works for you. So if I look at this guy, my 8 and my 4 can cancel. And so I have y equals, and it would be the sine, 2 first. 8 divided by 4 is 2. Put that in front. 2 sine of 4x plus c. So that one's not too bad, not too crazy bad. Again, on the notes, when you see what I scan in for the answer key, you're going to see it done as a u substitution. But this way is kind of a little bit easier. So here we go. We know that pi over 8 is x and that y is negative 2. Negative 2 equals 2 sine of 4 times pi over 8 plus c. And that's hopefully going to help me figure out what c is. This is pi over 2. So I have negative 2 equals 2 times, if I take the sine of pi over 2, that's up at the top of the circle, that's the coordinate 0, 1. The y coordinate is 1, and so there you go, it's a 1 plus c. If I take this positive 2 and swing it to the other side, I get a c value that's negative 2, and so therefore I know my equation is y equals 2 sine of 4x minus 2, my c value. That's number 3. The second one I picked is number 5, because 5 is one of those two-steppers again. So I picked one with a trig function. This one's going to involve ln's. So that's kind of why I chose this next one. So here I am, number 5. I need to go backwards twice. They gave me the second derivative. Oh, can't say it. Hold on. Make it so you can see it. They gave me the second derivative, and they want me to go to the actual original equation. So I've got to go backwards twice. I'm setting this up so that I can integrate it and get down to dy over dx. If I integrate 1 over 2 minus x squared with respect to x. And then I've also got a plus 1 dx. There's no way around, I don't think, that first term using a u substitution on it. So I'm going to come over here and think about, I should have done it on the left there if I had space, but I didn't. My u is going to equal 2 minus x. My du is going to equal a negative 1 dx. I have not a negative 1, I have a positive 1, so negative du equals dx. I'm going to put that into my integral, and that means my integral is going to be 1 over u squared times negative, I'll put that out in front, du. And then I've got this part here, and the integral of 1 is just an x, and I'm going to need a plus c at the end. So now I got to play around with this front end guy, right? He would be like u to the negative 2. And if I integrate u to the negative 2, it is negative u to the first over negative 1. So negative 1 over u plus x plus c. Now negative negative makes it positive. I have 1 over, instead of u, it's 2 minus x plus c. So that's round 1. Round 1 gives me that for my answer. But they told me some information so I can find c. They said that when x, go to the first derivative guy, when x is 3, y is 6. So I have 6 equals 1 over 2 minus x of, x is 3, plus 3 plus c. And that's supposed to give me enough information for me to be able to figure out what c actually is. So if I look at this, let's see. This is 1 over negative 1. That's negative 1. Negative 1 plus 3 is 2. 2 swings over to join with the 6. So I get a c value that is 4. c equals 4. Which means that my first derivative is y equals, dy over dx equals 1 over 2 minus x plus 4, my c. But I've got to take the second round on it. So the second round now I'm going backwards again, and this time I want to know what y is. Well, y is the integral of these pieces. Integral of 1 over 2 minus x plus the integral of x. This one I really didn't have to separate. You probably could have done this all at once, but that's okay, since we separated the others. Do you remember what the integral of a 1 over something is? So the 1 over something ends up to be an ln, right? So if I'm looking at this one, if I'm taking, I've got to then take the ln of 2 minus x. All right, so here I go. Y equals the ln of the absolute value of 2 minus x and then I am feeling like I need to divide that by a negative 1, but I did not do that on the practice problems. So I'm going to think for a second. I'll come back to that in class, but we're going to leave it as 2 minus x because that's kind of what the answer key was talking about. Plus the integral of x is x squared over 2, and the integral of 4 is a 4x, and we're going to do a plus c. And so if I look at this, taking it the next step, they gave me information enough to be able to figure out what c is. If I go back here, they said when x is 1, y is 4. We say, okay, here we go. 4 equals the ln of 2 minus 1. 1 was it? Yes. 2 minus 1 plus 1 squared over 2. You can see I flipped my page here. Plus 4 times 1 plus c. I think I want to go back and make this over a negative 1. my math, my calculus brain is going. But yeah, when you do that, you got to divide by whatever the coefficient on that derivative would be. Like chain rule, you're undoing the chain rule. So I have a negative x. If I take that, there's a negative 1 that's involved. But because it's integrating, you're dividing by that negative. And so there you go. After I thought that through a little bit more, here it is. So I'm looking at how my solution is going to go here. 4 equals negative ln of 1, well that's a 0. And then I've got 1 squared is 1, so 1/2. And then I've got a plus 4, and then I've got a plus c. So let's see if we can figure this out. Now if I take these 4s and combine them, they are canceled, or I guess you could look at it this way too. 4 equals 4.5 plus c. If I take 4.5 away, then c is going to equal a negative 1/2. And now I have enough information to put my whole y together, which is this guy. Y equals negative ln of 2 minus x plus x squared over 2 plus 4x and then minus a 1/2. That, I know we don't like to box answers, but that's my final answer for that guy. That's number 5. And one last one I'm going to do with you, and that is number 8. Number 8. I know this is a long section, but the more I do, the less you have to do, right? This is one of those solve for k deals, and so they give us a function that's y equals. They give us a differential equation that involves a second derivative and it involves a y, and we've got to figure out what the k is. We're looking for k. So if they give me the original function, I need to go to the second derivative because that's what I'm going to be plugging in right here. And again, these are right small if you're using the boxes because there's really not enough space. In fact, funny enough, look at my number 8 when I did it. This is what's going to be scanned in. I had to go sideways in order to fit it all in. So I'm going to do it on other paper so I don't get you lost in the midst of my sideways work. But nonetheless, here we go. First derivative. K sine of negative x. Well, k is a constant. The derivative of sine is cosine of the same angle times the derivative of the angle. Looks like that. Oh, the dogs are going by. Plus 2. Derivative of cosine is negative sine of the same angle times the derivative of the angle. And so put it together. So it's going to be a negative k cosine of a negative x. I've got 2 times 3 is 6, but it's negative. Sine of 3x. So there's my first derivative on this, first take. I need to get to the second derivative so that I can plug it into the equation they gave me. So again, k is just a constant. This isn't a product rule, it's just a number. It's representing some kind of a number. So this is going to be negative k. The derivative of cosine is negative sine of the same angle times the derivative of the angle. Derivative of sine is cosine of the same angle times the derivative of the angle. And then we've got to put it together. Now watch, these signs are kind of really weird, the positive and negatives here. You have negative times a negative is positive, but that positive times this negative is a negative. And by the way, you're not using this angle as part of that decision. This is just talking about the angle itself. So we're looking at the outer signs here, and they turn out to be a negative. I have negative k sine of negative x, and then I have 6 times 3 is 18. 18 cosine of 3x. Oh, minus, right? This is a minus. Okay, that's better. Well, now I have all the information, and now it's a matter of plugging it into this equation right here. And this is where it gets really, really long. So I've got 2. I'm going to come way over here, see if I can put it all on the screen. I am looking at this differential equation right here, 2. And then it's times the second derivative. Well, all of this is your second derivative. Negative k sine of negative x minus 18 cosine of 3x. 2 times y double prime, that's what this is, plus. Then it says 18 times y. Well, here's 18, and here's what y actually is. It's the original equation. So it's going to be 18 times my y of k sine of negative x plus 2 cosine of 3x. That takes care of this, equals 32 sine of negative x. Shoo. Now all of this is going to help us find k, believe it or not, in the midst of this craziness. So we're going to distribute the 2 and the 18 and see where that lands us. I have a negative 2k sine of negative x, and then 2 times 18 is 36 cosine of 3x. I have 18k sine of negative x, and I have 18 times 2 is 36 cosine of 3x is supposed to equal 32 sine of a negative x. Now, just like before, we're hoping that the terms that do not have k's in them cancel out. So let's check it out. I have a negative 36 cosine of 3x and a positive 36 cosine of 3x. Bye-bye terms. I have negative 2 yada yada, and I have 18 of the same yada yada. So I've got 16 ultimately. K sine of negative x is supposed to equal 32 sine of negative x. All right, can you solve for k? Get k by itself? That would be 32 sine of negative x. I'm almost out of space on the screen. Over 16 sine of negative x. And so when you divide them, you get a k value. That's 2. All right, that takes care of the examples and practice problems for section 7.2. I know this was a little longer one. There's a lot of algebra details in this, but none of the concepts are really all that crazy hard. Just be careful of your algebra in the midst. And shoot me an email if you have any questions. I'll see you in class.